believe this is where we left off. Remember, we were talking about arc length. S equals r theta was our formula. What had to be true about theta in order for that to work? Had to be in radians. Degrees do not. Okay. So a rope is being wound around a drum with a radius of 0.327 meters. How much rope will be wound around the drum if the drum is rotated through an angle of 120 or 132.6 degrees? So if I'm talking about how much rope, the rope is going around the outside. What variable is the distance around the outside? Well, what are we calling it? Circumference is all the way around. That's my arc length. That's what I'm trying to find here. I know my radius. And I am looking for my S. I know my angle is 132.6 degrees. So what do I need to do here? Convert to radians. How do I change degrees into radians? Times pi over 180. Okay. So I'm not going to plug in the pi. I'm going to do 132.6 over 180. You get a repeating decimal, so go ahead and give that to me in fraction form. So that's 221 pi over 300. You want to be careful because I'm going to use this theta in a formula. So if you round your theta now, what does that do to your final answer? It's going to throw that off. So try to avoid rounding earlier in the problem. So now we can just do the S equals r theta. My radius is 0.327 theta, 221 pi over 300. Okay, and we talked about all the different ways that you might answer these questions. You know, you could give me the decimal with a pi on it. This one, if you try to turn it into a fraction, does it go? No. You're also welcome to just go ahead and say times pi, especially in these application problems. If I'm talking about a distance, a lot of times, unless it's a nice number, you would probably give me the decimal anyway. So if you want to go ahead and multiply that out, give me like 4 decimal places. And since I multiplied out the pi, I don't have my pi symbol on that one. The units, I told you arc length and the radius will always have the same units, so you could answer with either of those. Let's look at a more challenging one. 2 gears are adjusted so that the smaller gear drives the larger one. What does that mean? You're spinning the small one, which in turn makes the larger one spin. Okay. If the radii of the gears are 3.6 inches and 5.4 inches, and the smaller gear rotates through 150 degrees, through how many degrees will the larger gear rotate? Okay, let's find something a little bit different here. Let's organize our information. Okay, so the radius of the small, 3.6, and then the large is 5.4. I know the angle in the small one is 150 degrees. And I am trying to find the angle in the large one. And that is all I gave you. How am I going to find that?
Like do the ratio out of it, and then multiply your input degrees times the ratio.
Okay. How would you do your ratio?
3.6 over 5.4.
Okay, so we could think of it like that. I'm guessing everyone else is not like that. Okay, let's think about, so as the small one spins, that's what makes the large one spin, right? So what is the same in both of these gears? Right, the distance on the outside. What are we calling that? The arc length. These would have the same arc length. Now, do I have enough information to find the arc length for the small one?
Yes.
Then, if I had the arc length, could I find my theta over here?
Yes.
Okay, let's do it like that. Okay, can I use 150 degrees? No. Okay, let's see if you can do this without converting.
Oh.
150 is in quadrant 2. Reference angle is 30. Right? We were doing that on the last test. 180 minus 150 is 30. Okay, in 30, what was our denominator when we had it in radians? Okay, and in quadrant 2, we said the numerator is 1, 5 pi over 6. Now, you could get that by doing 150 times pi over 180. But I just want to take this opportunity to practice the ones that we are trying to become more familiar with. Okay? So now let's find our S. So S is 3.6 times 5 pi over 6. And we get 3 pi. But the nice thing is, if I have my S for the small, that's the same as my S in the large one. So if I want to do a S equals R theta, plug in what we know. The S is 3 pi. The R is 5.4 times our theta. And so I get my theta to be 5 pi over 9.
So can you just set R theta equal to the other R theta?
Okay. Am I done? What's wrong with that? I said through how many degrees. This is not degrees. So how do I change that to degrees? 180 over pi. So the pi's drop. And we get 1 over 6. Okay, so we have to use that arc length piece that they share to get to our answer. And then just always make sure you're answering the question that was asked. It said degrees. Questions on that? The next thing I want to talk about is area of a sector. A sector is a portion of a circle. Okay? We could think of this in terms of a proportion. So if I'm trying to find the area of this for a given angle, let's think of it in terms of a full circle. How do you find the area of a circle? Pi r squared. Okay, in terms of radians, how far is it if you spin all the way around a circle? What's your angle? That's 360 degrees, which in radians is 2 pi. Okay, so if I were trying to solve this, what would happen to my pi's? They cancel. You would multiply over your theta, so you get r squared theta over 2. Or a lot of times, I'm going to write that as area equals 1/2 r squared. So that is how you find the area of a sector, a portion of a circle, without doing the full thing. So that is the second formula that we need. We have the S equals R theta, and then we have the area formula. When when it comes time for tests and quizzes, you will have a formula sheet. There's a section, haven't looked at 90% of what's on here, but both of these formulas are right here on the top. S equals R theta and area equals 1/2 R squared theta. So you don't really have to memorize them, but you have to recognize them, know what your variables stand for, and know that theta has to be in radians for it to work. Alright, and so the next slide I just put the formula there. So first I showed you where it came from. Alright, let's do an area problem. Find the area of a sector of a circle having a radius of 15.2 feet and a central angle of 108.0 degrees. So I know my R, I know my theta. Any problems with that? It's degrees, so let's change it to radians. How? Multiply by your pi over 180. And we get 3 pi over 5. So then area is 1/2 R squared theta. So plug in our stuff. Okay, lots of ways you could write your answer. If you don't put the pi in, you get 69.312 pi. Or you could say 8,664 pi over 125. Or if you do go ahead and multiply out the pi, how many significant digits did we have in the problem? 4. So if I wanted to give it 4 significant digits, I would say 217.8. What kind of units do you use for area? Square. So 217.8 square feet. I would like for you guys to try the next example on your own. So read that and see if you can find the answer. So we have a lawn sprinkler in the corner of the yard. It rotates through 90 degrees. So what's that telling you? Your angle, your theta is 90 degrees. Okay, we don't even really need to calculate that. We should know 90 degrees is the same as pi over 2. Okay, it projects water out 30 feet. What is that? Your radius. So it's going to go around like this, and we are trying to find that area right there. So area equals 1/2 R squared theta. So we get 225 pi. If you did multiply that out, it's like 706. How many significant digits? We had 3 for that distance. It's like 706.86, or if you round it to significant digits, 707. My units would be square feet. What?
I rounded. Yes.
A lot?
No, 770.
Okay, there you go. All right, so couple things. We are going to have homework now, and we've got a lot of time to work on that. And then remember I told you, what are we having tomorrow? A quiz. Do you want to talk about what's going to be on this quiz first? Okay. All right, so we will start with section 3.1. And we did basic conversions there. So I might say like convert 17 degrees, 25 minutes to radians. Or maybe negative 3 pi over 4 to degrees. Do we know how to do those? So it's either multiplying by 180 over pi or pi over 180. Do you guys want me to work through those examples, or?
Do the first one just because I wrote it down.
Okay. So if I were putting this in my calculator, I'd have to do 17 plus 25 over 60 when I plug this in. It's in degrees, so you want your degrees to cancel, so you multiply by pi over 180. So if I put that in, usually I try to leave off the pi if I can. So you could write it, this one does come out to an ugly fraction, but you could say 209 pi over 2,160. Or, since it's kind of ugly, if you did multiply in the pi, you could say 0.304 radians. So is that one okay? And the second one, you would just multiply by 180 over pi. So that was the first thing we did, conversions. There will be a large section that says, find the exact value. Remember that little half sheet of paper I gave you the other day, 10 questions? We did it as a practice quiz. It's going to be like those types of questions. We'll probably have another one of those little practice quizzes, well, maybe a real one, probably at the end of the week too, because I want you to start getting the hang of this. So I might say something like the secant of 5 pi over 3. And I expect you to evaluate that. What are the two pieces of information you have to write down? Quadrant, reference angle. Okay, 5 pi over 3. Remember, in the first quadrant, it's just pi. In the second, it's 1 less. The third, 1 more. The fourth, double minus 1. So what's this? Quadrant 4. Reference angle, if you're in radians, it's easy. It's just pi over your denominator, so pi over 3. So first of all, if I have secant, I'm thinking about cosine. In quadrant 4, is cosine positive or negative? Positive. Okay, pi over 3, that's like what degree measure? 60 degrees. Okay, so cosine of 60 would be 1/2. That means secant is 2. So you should be able to evaluate those. There was one on the homework that I know got a lot of you, or I think there were like 3 of them. It said tangent of, let's do negative, let's do negative 7 pi. Okay. What did we do if we had a negative angle? We added 2 pi to it. 360 is the same as 2 pi. You can do it on your calculator, you just don't do the pi, so you do negative 7 over 6 plus 2. And so that gives you tangent of 5 pi over 6. What quadrant is 5 pi over 6 in? Quadrant 2. Reference angle would just be pi over 6. Pi over 6 is the same as what degree measure? 30. In quadrant 2, is tangent positive or negative? Negative. And then tangent of 30 would be radical 1 over radical 3. So radical 3 over 3. So like what we were doing back in degree measure, just I'm going to give you the question in radians. Okay, that was like the last page of our last test that we took. Any questions on those? So that's really the section 3.1 stuff. 3.2, you're getting ready to work on that homework, so I'm probably not going to do any of those right now, but we might do a couple tomorrow after we grade the homework, if we need to. Does that sound good? Okay. So, for your assignment, make sure we are not doing all of these. I'm going to knock off a few of them, I think. Not good. So this is what was printed on your notes, but I told you I was going to make it a little bit shorter. So 12 problems.